This video covers Chapter 2, Cloud Computing Technology, Part 2. This portion of Chapter 2 focuses on cloud computing standards and service providers for the cloud computing module. We begin with Section 2.4, Cloud Computing Standards. These are the rules, guidelines, and frameworks that ensure compatibility and safety within the cloud environment. Cloud computing involves many providers, many users, and many systems working together. For example, you may store files in Google Drive, run an app on AWS, and use Microsoft services at the same time. All these providers must connect properly. That is why standards are needed to ensure compatibility, safety, and consistency. Compatibility means different systems can work together smoothly, like different phone brands using the same Wi-Fi. Safety means data is protected from hackers. Consistency means services work in a stable and predictable way. Without standards, cloud systems would not work well together, and users would face many problems. Now let us understand the meaning of cloud computing standards. What are they? They are agreed rules and guidelines. This means common rules that everyone accepts. These rules are accepted by cloud providers and organizations, so everyone follows the same way of working. For example, think about traffic lights. Because everyone follows the same rules, cars move safely. If each driver creates their own rule, there will be chaos. Standards define how systems operate, meaning how computers and servers run and communicate. They define how data is handled, such as how files are stored, shared, and backed up. They also define how security is maintained, which means protecting information from hackers. Standards help create trust in cloud services because users know the system follows proper rules. Cloud standards have several important purposes. First, ensure service quality. This means cloud services must work properly and give reliable performance. For example, when you submit an online assignment, the system should not suddenly crash. Reliable means stable and dependable. Second, protect users and data. Standards provide rules to keep personal information and company data safe. This includes passwords, student records, and financial details. Third, support system integration. Integration means different systems can connect and work together smoothly, like AWS, Azure, and Google Cloud sharing data. Finally, promote best practices. Best practices are proper and professional ways of managing cloud services. Overall, cloud standards guide providers and users to create a safer and more organized cloud environment. Interoperability means different systems can work together. In cloud computing, this means different cloud platforms can connect and communicate, and data can move easily from one platform to another. For example, a company may start with AWS, then later move some services to Google Cloud. If standards are followed, the migration is easier. Migration means moving systems or data to another cloud. Standards help avoid vendor lock-in. Vendor lock-in means users are forced to stay with only one cloud provider. Standards also support system migration and improve flexibility. Flexibility means organizations can choose services that best fit their needs. Interoperability is important for long-term cloud use because companies grow, technology changes, and prices change. Standards give freedom and better control over systems. Cloud standards address security issues such as data protection, access control, and risk management. First, data protection. Standards ensure that user data is stored and transmitted securely. Transmitted means data sent over the internet. For example, when you upload an assignment, it should be protected from loss, leakage, or unauthorized changes. Second, access control. Standards define who can access systems and data. Only authorized users can log in and perform certain actions. For example, only lecturers can edit marks. Third, risk management. This means identifying possible threats and managing risks properly. Providers monitor systems and prepare recovery plans in case of attacks or system failure. Overall, security standards help providers follow safe practices and make users feel confident using cloud services. Here, we look at the role of international standard organizations. These organizations develop cloud standards to make sure cloud services follow common rules around the world. Examples include ISO, which creates standards such as ISO 27001 for information security, and NIST, the National Institute of Standards and Technology from the United States, which provides cloud definitions and security frameworks widely used as references. Another example is IEEE, which develops technical standards for networking and communication. First, they publish guidelines. Guidelines are official documents that explain how cloud systems should be designed and managed, like a school handbook that tells everyone the rules. Second, they define frameworks. A framework is a structured plan that shows how security, management, and operations should be organized. Third, they promote global best practices, encouraging companies worldwide to follow the same high standards. Because of these organizations, cloud services follow accepted rules worldwide. This increases trust, safety, and reliability in cloud computing. Here, we discuss ISO and cloud computing. ISO develops standards used globally. In cloud computing, ISO standards focus on information security, data management, and service quality. Information security means protecting data from hackers, leaks, and unauthorized access. For example, when you log in to an online banking app, your password and personal data must be protected and kept confidential. Data management ensures data is handled properly. This includes storing, processing, and backing up data in a secure and organized way. For example, a university must store student records safely and make backup copies. Service quality ensures cloud services are reliable and perform well. Availability means the system is always accessible when users need it. Many cloud providers follow ISO standards. This shows their services meet international requirements for security and quality. Now, we look at the importance of ISO standards. ISO standards are international rules that guide how systems should be managed. They help ensure reliable services, which means the system works properly and is available when users need it. For example, imagine online banking. You expect it to work anytime, even at night. That is reliability. Next is consistent operations. This means the provider follows clear rules and procedures every time, not randomly. Think of a fast food restaurant. You expect the same taste and quality each visit. That is consistency. Then we have proper data handling. This means data is stored and managed carefully to avoid loss or misuse. For example, your medical records must be protected and not shared without permission. Many organizations prefer providers that follow ISO standards because it shows they follow trusted international rules. In this slide, we discuss NIST and cloud computing. NIST stands for the National Institute of Standards and Technology. It provides clear cloud definitions and frameworks, which means structured guidelines that help everyone use the same understanding. First, NIST explains the cloud service models, SaaS, PaaS, and IaaS. For example, SaaS is like using Gmail. You just log in and use it. PaaS is like renting a ready kitchen to cook your own recipe. IaaS is like renting land and building your own house. Next are deployment models: public cloud, private cloud, hybrid cloud, and community cloud. A public cloud is shared, like public transport. A private cloud is for one organization only. Hybrid combines both. Finally, security guidance means NIST gives rules to help organizations protect their systems and data. Many universities and industries follow NIST because it gives trusted direction. Why NIST is important for learning cloud. First, NIST uses clear definitions. This means cloud terms like SaaS, PaaS, IaaS, and cloud deployment models are clearly defined. When definitions are clear, everyone understands the same meaning. For example, in a football match, rules must be clear so all players play fairly. Next, NIST explains cloud concepts systematically. Systematically means in a logical and structured way, step by step. It is like learning mathematics. You start with basic formulas before solving harder questions. NIST is also often referenced in exams and textbooks. Many exam questions use NIST definitions. So if you understand NIST, you are better prepared. Overall, NIST provides a common understanding. It helps everyone learn and discuss cloud using the same standard definitions. Here, we learn about standards and compliance. Compliance means following established standards and meeting legal and policy requirements. In simple words, it means following the rules that are already set. Cloud providers must comply with security standards to protect systems and data. For example, providers such as AWS or Google Cloud use strong encryption, identity controls, and continuous monitoring to prevent hacking and data theft. It is similar to locking your house doors and installing CCTV so only authorized people can enter. They must also follow data protection rules to keep user information safe. Think about your bank details or medical records. These rules make sure personal data is not misused or exposed. Finally, they must follow industry regulations, which are legal requirements set by authorities. For example, they may comply with GDPR, General Data Protection Regulation, in Europe to protect personal data, HIPAA, Health Insurance Portability and Accountability Act, in the United States to protect medical information, and Malaysia's PDPA, Personal Data Protection Act, to safeguard user data. Why it matters. Compliance reduces risk for users and increases trust in cloud services. When a cloud provider follows standards, users receive real benefits. First, better security. This simply means your data is better protected because the system follows proper security rules. Think about using an online banking app. You trust it because there are strong passwords, encryption, and monitoring behind the scenes. Standards make sure those protections are always in place. Second, higher reliability. Reliability means the service works when you need it. Imagine an online shopping website during a big sale. Thousands of people are buying at the same time. If the system crashes, the company loses money. Standards help providers design systems that are stable and available. Third, clear service. Standards clearly define what the provider must deliver. Users know what level of service to expect. It is like signing a rental agreement. Both sides understand their responsibilities. Overall, standards protect both the provider and the user. They build trust and reduce misunderstandings. Now we go to Section 2.5, Cloud Computing Service Providers. In this section, we will see the roles, types, and major global providers of cloud infrastructure and services. A cloud service provider is a company that offers servers, storage, and other IT resources through the internet. Instead of buying your own equipment, you rent and use it online. This makes it easier and more flexible for businesses. Let us understand what a cloud service provider really means. It is a company that offers cloud computing services to users. These providers own cloud infrastructure. That includes data centers, servers, storage, and network equipment. A data center is simply a large facility filled with powerful computers. Instead of buying and maintaining this hardware yourself, you use theirs. It is similar to using electricity from TNB. You do not build a power station at home. You just use the service. They also deliver cloud services through the internet. Users can access storage, applications, or even virtual machines online. A virtual machine is like a computer created by software. It behaves like a real computer, but it runs inside a bigger system. At the same time, providers manage cloud operations. They handle maintenance, security, updates, and system monitoring. Monitoring means checking the system regularly to ensure everything runs smoothly. This is why it matters. Users can focus on their work instead of managing technical systems, while the provider takes responsibility for the infrastructure and daily operations, making services run safely and efficiently. Let us look at the role of cloud service providers. Cloud service providers are responsible for many important tasks behind the scenes. They handle hardware management. This means managing physical servers, storage devices, and networking equipment inside data centers. These are the real machines that store and process data. It is like a factory owner taking care of all the machines so customers do not have to. They also manage software platforms, including operating systems and cloud platforms. An operating system is the main software that controls a computer, such as Windows or Linux. Because the provider manages it, users can run applications without installing or maintaining system software themselves. Another key role is security controls. Providers implement security measures such as firewalls and data protection. A firewall is like a digital security guard that blocks unwanted access. These controls help protect systems and information from attacks. Finally, they ensure service availability. This means services are running and accessible. Providers monitor systems to reduce downtime, which is the time when a service is not working, and fix problems quickly. Why is this important? Users do not manage the underlying systems. They focus on using the service, while the provider handles the technical responsibilities. Cloud service providers offer different types of cloud services, and there are three main categories. First is infrastructure services, also known as infrastructure as a service or IaaS. The provider offers virtual servers, storage, and networking. A virtual server is like renting a computer inside a data center. For example, Amazon EC2 or Google Compute Engine allows companies to rent virtual machines to host websites or business systems. During a big online sale, a company can quickly rent more servers instead of buying new hardware. Users control their own systems and applications, but the provider manages the physical machines. Next is platform services, or platform as a service, PaaS. The provider offers a platform for developing and running applications. A platform means a ready environment with tools and software prepared for developers. For example, Google App Engine or Microsoft Azure App Service allows developers to upload their application code, and the platform handles servers and system setup. It is like renting a fully equipped kitchen. You focus on cooking, not building the kitchen. Finally, software services, or SaaS. The provider offers ready-to-use applications through the internet. Users simply log in and use the software, such as Gmail or Microsoft 365. Some providers offer all three types of services. Many global cloud providers operate on a large scale. They run data centers worldwide. A data center is a secure building filled with servers that store and process data. Because they have data centers in many countries, services can be delivered from different locations. For example, when you stream Netflix or use Google Drive, the system connects you to the nearest data center. This makes access faster and more stable. These providers serve millions of users, including individuals, companies, and governments. For example, a small online shop and a large bank may both use the same cloud provider. They also support businesses of all sizes by offering different service plans. A startup may choose a basic plan, while a large company selects a more advanced one. This global presence improves performance and reliability, meaning services run smoothly and are available when needed. Amazon Web Services, or AWS, is one of the largest cloud providers. It offers computing services, such as virtual servers using Amazon EC2. A virtual server is a computer that runs in the cloud. For example, an online shopping website can run its application on EC2. Lambda allows serverless code execution, which means developers run code without managing servers. Next are storage services like Amazon S3 and EBS. S3 stores files, images, and backups online. For example, a company can save customer photos in S3 and access them anytime through the internet. AWS also provides networking services such as Amazon VPC and Elastic Load Balancer. AVPC creates a private network inside AWS. This is important when a company wants better security and control. For example, a bank may place its database inside a private network, so it is not directly exposed to the public internet. Only approved systems can access it. The load balancer distributes traffic across multiple servers, so the system stays fast and stable. That is why many enterprises rely on AWS for cloud services. This illustration shows a few of the many AWS cloud products organized into categories like compute, storage, databases, networking, security, and analytics. The strengths of AWS include a wide variety of services, high scalability to easily adjust resources, and a strong global infrastructure with many data centers. This makes AWS suitable for complex, large-scale systems and heavy workloads. Microsoft Azure is a major cloud platform by Microsoft. It is well known because it integrates easily with Microsoft products. Azure works well with Windows systems. Many organizations already use Windows Server in their offices. With Azure Virtual Machines, they can run Windows Server in the cloud instead of buying new physical servers. For example, a company can move its Office system to Azure and access it remotely. Azure Backup can also back up Windows Server data securely. Azure also connects smoothly with Microsoft software such as Office 365 and SQL Server. For example, a company using Outlook, Teams, and SharePoint can store files in Azure and manage databases using Azure SQL Database Server. Integration means different systems work together without problems. This makes management easier for existing Microsoft users. Azure is designed for enterprise environments, which means large organizations with many users and systems. It provides tools like Azure Virtual Network for secure private networks and Azure Site Recovery for disaster recovery. Disaster recovery means restoring systems quickly after a failure. That is why Azure is popular among organizations already using Microsoft products. This graphic displays the range of Microsoft Azure products, including categories such as compute, containers, storage, databases, networking, security and identity, and analytics. The strengths of Microsoft Azure include strong enterprise support, hybrid cloud capabilities to connect local and cloud systems, and integrated security features. Azure is widely adopted in corporate environments and suitable for complex business systems. Google Cloud Platform, or GCP, is Google's cloud offering. It focuses strongly on data processing, analytics, and performance efficiency. For data processing, GCP provides tools to process large amounts of data, also called big data workloads. For example, Google Cloud Dataflow helps process streaming data in real time, such as tracking ride requests in a transport app. Cloud Dataproc runs big data tools like Hadoop and Spark for analyzing large datasets, such as sales records from thousands of stores. In analytics, GCP offers services to study and understand data. BigQuery is a powerful data warehouse that allows companies to analyze millions of records quickly, like analyzing customer buying patterns. Looker helps create dashboards and reports so managers can gain insights from their information. For performance efficiency, GCP focuses on speed and efficient system performance. Google Compute Engine provides fast virtual machines to run applications. Cloud CDN speeds up content delivery, so websites load quickly for users in different countries. That is why GCP is known for innovation and speed, especially in data and analytics solutions. The Google Cloud Platform products are extensive, covering areas like compute, containers, storage, database, networking, and data and analytics. Let us look at the strengths of Google Cloud Platform. One major strength is data analytics. GCP provides powerful tools for analyzing large amounts of data. Data analytics means studying data to find useful patterns and information. For example, an online store can analyze customer buying history to see which products sell more during holidays. From this, organizations can gain useful insights and make better business decisions. Another strength is machine learning services. Machine learning means teaching computers to learn from data and improve automatically. GCP offers services for building and running machine learning models. For example, a company can build a system that recommends products based on customer preferences. This helps users develop intelligent applications more easily. GCP also has high-performance infrastructure. Infrastructure refers to the servers and networks that support applications. GCP uses fast and reliable infrastructure, so applications can run with high speed and efficiency. For example, a mobile game used by millions of players needs strong performance to avoid lag. That is why GCP is popular among technology-focused organizations and suitable for data-driven and innovative projects. When choosing a cloud service provider, several important factors must be considered. First is cost. The price of services must match the organization's budget. Different providers offer different pricing models. For example, a startup may prefer pay-as-you-use pricing to avoid high upfront costs. A large company may choose a long-term plan for lower overall cost. Next are security needs. The provider must meet the required security level. If a hospital stores patient records, sensitive data needs stronger protection, such as encryption and strict access control. Encryption means converting data into secret code to prevent unauthorized access. Then comes service availability. The service should be reliable and always accessible. High uptime is important. Uptime means the percentage of time the system is working. For example, an online banking system must be available almost all the time to avoid customer complaints. Finally, consider the skill level of users. The provider should match the user's technical skills. Some platforms are easier to manage. A small company without IT experts may choose a simpler service. There is no single best provider for all cases. The right choice depends on specific needs and goals. Let us talk about cost considerations in cloud computing. Cloud providers charge based on how services are used. First is resource usage. Users pay for the computing resources they use. Computing resources mean virtual servers, memory, and processing power. More usage means higher cost. For example, if an online store runs many servers during a big sale, the cost will increase because more resources are used. Next is storage size. Users pay based on how much data they store. Larger storage requires higher payment. For example, if a company stores thousands of customer photos or videos in the cloud, the bill will be higher than storing simple text files. Then we have data transfer. Charges may apply when data moves in or out of the cloud. For example, if many users download large video files from a website, high data transfer can increase costs. Data transfer means sending data across networks. Why this is important? Users must understand pricing to avoid unexpected costs. Careful planning helps control cloud expenses and manage budgets effectively. When businesses move their systems to the cloud, reliability and support become very important. A reliable provider ensures high uptime. Uptime means the service is available most of the time, while downtime is when the system stops working. For example, imagine an online food delivery app during dinner time. If the system goes down, customers cannot place orders, and the company loses sales. That is why providers work to keep downtime very low. Then there is technical support. Providers offer help when problems occur. Users can contact support for assistance. For example, if a company's cloud database suddenly cannot be accessed, the support team helps troubleshoot and restore it quickly. Another key part is service level agreements, SLAs. An SLA is a formal agreement that defines service performance. It includes uptime guarantees and response times, which means how quickly the provider responds to issues. Reliability is critical for business operations. System failures can affect productivity and revenue, so uptime, support, and SLAs really matter. Cloud services do not operate freely without rules. There is a strong relationship between standards and providers. First, providers must follow industry standards. These are accepted industry guidelines that define best practices. Standards ensure quality and consistency. For example, when you use online banking, you expect the same level of security every day. Standards help providers design systems that work in a consistent and reliable way. Next, providers implement compliance measures. This means they apply rules to meet legal and regulatory requirements. Regulatory requirements are laws set by governments. For example, a cloud provider storing health records must follow data protection laws to protect patient information. This helps protect data and user rights. Finally, providers publish certifications. Certifications are official proof that they meet certain standards. It is similar to a restaurant displaying a hygiene certificate. Certifications increase trust and transparency, which means users can clearly see that the provider meets required standards. Standards guide how providers design and deliver services. They help ensure security, reliability, and accountability. In summary, cloud providers deliver and manage essential services. Industry standards from organizations like ISO and NIST ensure safety and consistency. Remember, the choice of provider heavily impacts cost, security, and performance. Thank you for watching this video on cloud computing. Cloud transforms infrastructure. Let us design it with care.